All right, let's shift to the notes. We covered the first part of the scientific revolution yesterday, and that's what the bell ringer was about. And then, of course, for the activity, you worked on the AP4 science. Hopefully, you were able to get that done. If you weren't, you can still have, after we're done with the notes, to work on that, where you picked a scientist not already picked by somebody else and described their contribution. You can see we already have some about Galileo, Robert Hooke, Rene Descartes, Francis Bacon, and Nicholas Copernicus. But going back to the notes, today we'll continue with them, and we'll start by talking about one of the most long lasting and celebrated scientists of this time period, which would be Isaac Newton. Isaac Newton in the notes. So, Isaac Newton himself as an individual was actually not really a great guy to know. He was incredibly secretive, obsessive, vindictive, petty. He wasn't known for being an incredibly popular person. He often worked alone. But as a scientist, though, he was incredibly extraordinary, especially in the field of mathematics. He believed that it was possible to dismantle all larger problems into smaller components and then work on them from there. And of course, corresponding with that, he was a big fan of Galileo's theory that the natural world could be described through mathematics. So, being that within the work of early physics, he developed the idea of universal gravitation and the idea of force. And by doing so, he basically opened up the human race to the idea that we could understand nature around us and perhaps to some extent control it. Some others to mention would include the followers of Descartes, which will be known as the Cartesians, which would be spelled Cartesians. That's Cartesians. That includes Blaise Pascal, who, of course, was a mathematician. Baruch Spinoza, which is spelled Baruch. That's Baruch. Spinoza, Spinoza. Spinoza. He was invested in geometry and ethics. So some of these people dabbled in more than just natural sciences. and Christian Huygens. Christian and then Huygens. Huygens. Who used math to explain orbital motion. Orbital motion. And then there are the Baconians, the followers of Francis Bacon. Remember, they're going to focus on observed evidence. This includes William Harvey, who dissected live animals to observe things like blood circulation. It also included Robert Hooke, Hooke. And Robert Hooke helped develop the microscope and discovered the cellular structure of plants. After observing such complex structure at the cellular level, he used that to prove that God existed, because after all, who could make such detail but some type of all-powerful being? And of course, this expanded, especially combined with William Harvey's studies to eventually look at animal cellular structure and how the two differentiate from each other. Something that you learn about in middle school science. And the last one I'll mention will be Robert Boyle. Boyle, which of course is famous for Boyle's Law. His studies included that of gases and pressure. And of course, some of his findings are studied in some of your high school classes. And on the outskirt of these camps, there would also be social changes within the sciences as well. As I alluded to earlier, some of these people advocated, especially like Francis Bacon, for more collaborative work. So, for instance, you would have royal societies established within some countries to bring scientists together, try to put together their research and discovery. You would also see patronage occur, so some wealthier individuals and families would help sponsor some of this science. And that was sometimes the only way that women could be engaged, but there were some female scientists at the time as well. That would include Maria Winkelmann. Maria Winkelmann discovered a comet. Also, Maria Marian. Maria and Marian is spelled Merian. She helped develop the field of entomology. Does anybody know what that is? Entomology? Entomology. That's the study of insects. Marian, Merian. And there are also people that advocated things within the scientific field, but maybe weren't necessarily scientists themselves, like Margaret Cavendish. Margaret Cavendish. Cavendish is Cavendish. Cavendish. She supported animal rights, often debated with men about the advancement of education of women, and she also wrote science fiction. Not quite the same as science.
She wrote science fiction in 1600.
She lived, let me see here. Yeah, 1670 to 17, or excuse me, 1623 to 1673. That is a good question. I would have to look that up. Can I name one off the top of my head? No.
Sociable letters.
And of course, one of science's important contributions during this time period would be to agriculture. So one of the changes that would happen with society would be in the field of agriculture. And there was a great need for change. Food supply was unstable, especially in the East. Many farmers resisted any type of change and did the same thing and planted the same crops over and over again, which we now know depletes the soil of nutrients. In rural areas, there are virtually no stockpiles of food. And so it was a simple notion of mathematics. The more people there were, the greater the growth population, the rise in prices of food would also occur.
What does science apply to agriculture?
Oh, I'll tell you. Iron would be used more and more in tools such as plows and drills for planting.
They using wooden tools before?
Yes.
Wooden plow?
I don't know about plows, but drills, yes.
Drills for what?
To plant seeds.
Seeds?
Yeah. The Dutch would drain large areas of land to uncover more that would be able to grow crops.
They do that to this day.
Yes, they do.
Big irrigation canals.
And then you have individuals like Charles Townshend. Charles Townshend, Townsend. Townsend. He helped develop modern fertilizer. And also the idea of crop rotation, planting different crops from year to year to year. So well known for his agricultural methods, he developed the nickname turnip. There, of course, was pressure to force people to take on some of these new means. And so Parliament, for instance, in England, and they kind of alluded this to in the film Cromwell, started to confiscate what used to be common land from the people to turn it over to nobles or middle-class businessmen who were willing to take some of these changes in agriculture in hand. So the people were sometimes resistant or couldn't afford, for instance, iron tools. And so in some cases, they were taking common land away from the people and turning it over to those willing to make the changes. The only change that really happened in Eastern Europe is something we talked about before, the introduction of things like corn and potatoes that at least allowed for greater production of food. Some of the results of these advancements would be population growth, mostly in the West. Urban population would end up rising because a lot of these newer techniques, especially using a tools, meant you needed less people. And so the surplus people would end up moving to cities to find work. So urban population switched from 5 to 9% during the 17th century. Towns of 10,000 people became common. But you started to see some of the problems that we often associate with the 1800s, but you started to see them in the 1600s. Richer folks living in the center of town in townhouses, while the poor tended to live closer to water sources like rivers and port fronts, and mostly in slums. A new middle class, though, of shopkeepers and artisans would often live in the apartments above their shop. So, for instance, downtown Titusville, there are the shops, and then there are apartments above. That actually, you can trace those roots back to as early as the 16 and 1700s.
I think it's just economical.
It is, but once business owners typically make enough money, especially by the 18 and 1900s, then they no longer want to live above their shop, and they buy houses on the outskirts of town. Eventually, by the 20th century, these would develop into suburbs, and it would also benefit from they could rent out the apartment above the storefront to make additional money. So it was at one time advantageous. But anyway, the middle class, of course, will continue to grow, but they will also start to resent the fact that the upper class nobles had a lot more rights and privileges, but it seemed like the only ones making advancements or running businesses were the middle class. The lower class, on the other hand, despite some of these adjustments with science and food, continued to live paycheck to paycheck and barely stayed ahead of inflation. This, of course, meant sometimes riots would erupt over food shortages and about some of the changes that legislatures would make, for instance, confiscating land. And then, of course, a group of people I want to just mention here would be Jews. Jews tended to live mostly in Eastern Europe. Mostly in Eastern Europe. Often isolated in their own part of communities, often called ghettos. Now, there can be two reasons for that. One is because often people within a Jewish community wish to keep to themselves, but obviously the other reason would be discrimination. Even when Jewish families lived in a country for multiple generations, they were still regarded as aliens, people not from the land. And of course, whenever there were any kind of social problems, such as food shortages, often Jews found themselves blamed, even if they didn't have anything to do with farming or agriculture. And so sometimes riots would occur, mob-led executions, confiscation of land and children to try to convert them to Christianity. And many of these types of situations were often known as pogroms, Pogroms.
How far would these little suburbs of one kind of people, how far would that be out in the city?
Often at the time, because cities were still compact and centralized, they would be within the city itself, a different sections only for them. Kind of like if you go to San Francisco, there's a Chinatown that's in the city, but it's just mostly of Chinese people. But anyway, Obviously, all of these situations, of course, are continuing to contribute to population growth. And in the past, famine and plague had often tried to basically bring about some type of balance, but population is going to continue to grow, which then puts more pressure on the need for an increase in food. But then, of course, the more food that's available, the more children that people have, or the healthier they live. So there's even more pressure to create more food. So it became kind of cyclical in a way. One of the parts of agriculture that's responsible for this, of course, is something we mentioned before, the introduction of the potato. Because of that calorie count increase, a lot of people today take that for granted because now everyone worries about watching their calories, but actually back then that was pretty significant advancement that occurred. And I will save the rest for later. So for the remainder of the period, you can go ahead and work on the scientist activity if you haven't finished that already, or go back and work on the reading that we started yesterday, or if there's something from Unit 3 that you didn't submit, you can go ahead and do that for the remainder of the period. The period ends at 1:29 p.m.